Hello, everyone. Welcome to another session where we learn Bitcoin smart contract together. So today, I think it's a little bit different format than previous sessions. So today, because we are going to teach you how to debug a smart contract written in script TS. So I think it's going to be like a pretty much hands-on demo. So there's no slides good to go over. And want to, again, make it interactive. So if you have any questions, feel free to interrupt me at any time. So just, before I dive into details, how many of you have used the debugger coming with Visual Studio Code before? Just a show of hand or shout out.
Yeah. Yes.
Okay. Okay, good. I did somebody. So pretty much we are just going to use the Visual Studio Code debugger because, as I said, this is the aim of script TS is pretty much just make it, almost the same with native TypeScript. So this is one of my, it's not one, it's my favorite part of the script TS because if you can just debug it as any other TypeScript code because it is TypeScript. So that means, I think today I'm going to, again, all the demos I'm going to use the Visual Studio Code. I think it's the most popular ideas out there today, and it's free, so you can download it. And there's no specific script debugger because it's a TypeScript, so we just use in the default debugger coming with Visual Studio Code. There's no, you just download Visual Studio Code and then you are ready to go. There's no other extensions or configs you have to do. So for people who have not tried Visual Studio debugging before, I think I'm going to put this link. So this is generic to all the debuggers, that how they work, how do they look, how do you start them, how do you configure them in the show notes. So today I'm not going to walk through the generic debugging because I think a lot of people who have any experience have using debuggers, this should be very straightforward. I think we are only going to use the basic features, like setting some breakpoints, look at the variables, watch some variables, and then look at the cost stacks, and then step through the code. So let's get started. So first of all, when we debug a smart contract, previously we covered about how do you write one and then how do you test one. So I don't know about you, but for me, usually when I write a contract for the first time, it doesn't succeed, right? It doesn't work out of the, just after the first try. So usually you have some kind of errors. And then how do you find why the error comes from, where the error comes from? So we generally have two ways, depending on, whichever way you like. So for the first one, of course, you can print out logs using console.log, So we have covered before. So if you are in a, smart contract context, most of the statements or functions and also global variables for default that's visible by TypeScript is not visible for us because, at the end of the day, it's a subset of TypeScript. So most of them are disabled by default. We have a few exceptions. Console.log is one. So for example, here, even if this is the smart contract context, right, is annotated with a method decorator. For example, add here, you can put a console log statement here, and then you can run the whole code. If you write some test code here, and then you can run, this is just normal TypeScript, right? Then you can run it and we'll print out all the values. So, this is the one way to debug it. We finished talking and then let's get something actually working to see how it goes. So again, I'm using, we have an example repo. Again, I'm also going to put the link in the show notes. So basically you have this kind of like a hello world smart contract we call demo. Previously we also covered, have a bunch of functions and then a bunch of properties. So here I already set it up so that I can put some, test code here, not test code, runnable script here. So you can pretty much just launch it. So everything, if it's a smart contract, internally, before you can use it to call its function, interact with it, it's like a initialize. You have to initialize it by calling this function, compile. So basically, what it does internally, but you don't have to know what's under the hood. But just as you know, anytime you want to, interact with the demo, you always have to initialize it by calling compile first. So internally, I mean, this is not necessary for you to understand to use this, but internally, this, compile down this smart contract down to so-called Bitcoin script. So, but for you, you just know, okay, anytime you try to use any smart contract, you call this first, and then it's like any other class in TypeScript, right? So you can, instantiate it, but create a new object, and then call the function on top of it. So here, we just, let me fold this. By the way, is this font big enough for you guys to see, or you want me to enlarge it?
No, I think it's big enough for me.
Okay, yeah, let me know
Nice.
if anybody who thinks it's not big enough. Let me make it a little bit bigger just in case. Okay, so once, let me run this. So here I also add a log here, just in the under method add, I put a console here to print out what is the Z value. So I can run it, if it's for people who are using TypeScript. So basically, usually you do it 2 steps, right? One, you first compile it using the TypeScript compiler down to JavaScript, and then you run it using Node.js. But also you have this kind of shortcut, TS Node. So basically it does 2, wrap them together. So basically compile it and then run it. So this is like a shortcut. So I'm just going to run this code and let's see what happens. So first it kind of, internally it compiles it, and then it just run the resulting JavaScript. So you can see, because I pass 5 here, I can print out the Z value here, right? So it's as if it's just native TypeScript. Any questions regarding this? Basically using, you print out logs. If you don't want, if it's something, maybe you think it's easier to fix, you don't have to go the full debugger mode. So that's something quick and easy for you to see. Yeah, straightforward. Okay. Yeah, I think this is should be the simple part, and then let's get down a little bit to the more advanced part. So basically, we use the Visual Studio Code debugger. So before, as I said, this is just normal Visual Studio Code debugger. So if you want to know all the full step spec and how to use all the features, this is official documentation. But for us, we just need to configure it so that you can run, our test, script test. So the good thing is, we have some, this is how you configure them from scratch, right? So you need to enable some options in test config, mostly source map, because this information we needed to know whether error maps back to TypeScript source code. So you have some, settings here, and then you also have to launch JSON. Launch.json is pretty much the config file that's, used by the debugger. So you also have to configure it, in this way. But the good thing is, we have the example. We have the example project, so everything is already configured out of the box. So we have configured, correctly the, TS config file. You can see here, we already have the source map enabled, but also we also have a default launch.json config. So it's already configured out of the box. So this spec, this is just for people who, who are not just starting from the example project. So they want to, use their own projects, and they want to set it up themselves. So you can follow the instructions here. But since we already, configured here, let's go to the debugger panel. So here, we already I already set it up, and also it's pushed to the repo if you can use it later. So, I already set up you can run demo here. So let's just get started. For example, we want to see, I want to, put a breakpoint here, and let's just, we can either click here. This is the debugger panel, or we can just say here. If you're on Mac, you can also just F5, and then it will launch the debugger. So you give it a little bit of time, and you should stop at one of the breakpoints. Okay, now it starts here. Let's see. Then you can see all the variables. That's correctly on the stack. You can see, it's just regular, TypeScript debugger. So you can set up different breakpoints. You can also look at the call stack, and also you can set up some variables to watch. So here, since now it's calling add function, add is coming here, and we have a breakpoint here, so we can just continue. So you should hit, right? So if it works, you should hit this next breakpoint. So let's see if it works. Okay. Let's move it. So let's keep going. Okay, as expected, it stopped at the next breakpoint, and then you can hover over. You can look at all the variables. For example, z is 5, and then if you really want, this is the function call in this line. If you want to see it, you can step in, right? So it's like just like any other TypeScript debugging. You can step into the function. Okay, now it goes into the sum method. You can also hover over to see all the variables. A is 2 and B is 3 because that's the number we're passing here, right? So no surprise. And once you hit inside, you can also step over to get out of the function. Okay, now step over, step out. It now comes back. And if everything works, you should exit without any error. Now it clears up everything. Okay. Seems easy to me. Any comments, questions here?
Not from my side.
Okay. Yeah, that's good. Meaning it's seems it's easy for everybody because, as I said again, always try to emphasize it's just normal TypeScript. So whatever way you debug TypeScript is carries the same. It's the same here. There's no new, debugging tricks you can pull here. Okay, so I just walk through this, and this is one way. You can have a main file. You can, for example, demo contract. You want to debug over it, or sometimes, and often, I would say, oftentimes, you put it. You want to do some kind of unit test, right, for your contract. For example, here, this is a demo smart contract, and also here we have a test file. As I said last time, I showed you how to write a unit test for your smart contract. I give examples using Mocha. So here, this is the old example we see last time. And again, I also configured. So basically, you can also follow instructions here. Basically, put all this code into your launch.json file, and then you can directly, launch debugger inside your testing file. So I already, as I said here, I already pre-configured this. So if you can see, I pretty much copied this code and put in the launch.json file. So so I just showed you how to launch demo just a few minutes ago, and now let's launch it also in the test, because a lot of times your tests fail, right? You want to find out what's going on there. You want to launch it from the demo test file. So pretty much I just copy the config here, and then go to debugger again. Let me go back. Actually, this is the test file. So I already, put a few breakpoints here. So if I, instead of launch demo, I can launch demo test. And then again, I can either click this, which I do, or you can hit F5. So it's going to take a few seconds, and we should hit one of the breakpoint here. Oh, okay, because this is the main file, so it's still running there. So let's keep going. Should come here. Let's not do this. Let's comment this out because this is just a demo. I want to show you how to run it from demo file itself. So it's not needed. Okay, building. You should hit some breakpoints here. Okay, this is strange. Okay, keep going. Okay, now, yeah, seems to something I think is out of date here. Never mind, it's going to be hit here. You are now in the test file, right? So you can look at again at all the variables, it's available here. And then you can also, keep going. For example, result, now you have the result because we add something. It's hit. Oh, we also set some breakpoint in the demo file itself. So now it hits here, but we can also keep going. It should come back. So, okay, now come back. It gives us the result. We can also hover over. It's like a regular TypeScript debug, right? You can hover over. You can see all the, the values of result is a struct. It has two fields, success field, whether the test is good or not, and then if not, it's error message. You can watch it here, or you can come here, over here. You can also expand it and look at it here, right? So again, you can keep going too if you want, and again you can look at the result here, or you can, if you want watch some variables, you can also in the watch panel, you can add it. So here you can look at, for example, I put result here. You can also look here. You can also look at all your open or active breakpoints in this panel, but also you can look at the code stack we're in right now. Okay, that's pretty much what I want to show today. And I just show you how to, either launch the debugger from the test files, from the file itself, or from its test. Any question here?
Nothing from me. Looks pretty good.
Yep.
Yeah. Okay. That's good. So you can also strongly, if you find the videos a little bit difficult to follow, but always you can go to here. It's documented here, so you can follow it over there. So let's stop the debugger right now, and then let's go to another type of debugging, I would say. So I just show you so-called, debugging when you have so-called run. So in script.js, there are two types of errors. Okay, one is so-called, I just showed you the runtime. Basically, you can run the smart contract is formatted well, the code is legit, but then when you actually run it, it has some logic errors. So that's one kind of error called a runtime error. So that's how you debug. The second type of error, we have a so-called compile time error. So basically it says, as I said from the very beginning, script.js is a domain-specific language, meaning, it's a subset. The syntax is a subset of TypeScript. So if it's legit, script.js code is valid TypeScript code, but not vice versa. So not all TypeScript code, you can put it in the smart contract context, right? So for example, here, I think at the very beginning, I also mentioned, for all the properties, you can only have 3 basic types. You cannot have other, you have big int, you have Boolean, you have a string. So what if I put some types that's not one of the 3? Let's say what we have. So I just, for example, here, I just put another property, say, hey, I want to put, let's say A here. And I use the type as a number. and then I try to compile it and see what will happen. So already, if you're familiar with Node.js, you can say, I just want to build it. Pretty much just invoke the TypeScript compiler, and then let's see what will happen here. So it's running the TLC is TypeScript compiler. And then instead of giving me, good to go, it reports some errors. So if you can see here, so-called errors. So this is because even though, the IDE, right, when you look at the editor, it doesn't give me any error because it looks, the TypeScript part is good, right? It's legit TypeScript, but it's not legitimate script.ts code. Because why? Because this type, we do not support it in property for a lot of reasons. I'm not going to mention, but basically this says this is not valid script TypeScript code. So it's giving me this error, says, hey, the number, you cannot transform it. You cannot put it in the property, pretty much. And then you should use the big int. And then it gives me the error, the file name, and also the line number. So this is kind of like, you can regard as a compile time error. And then you have to fix this. And then you can keep going. Then you can run the actual file, the contract. Okay, this is a special thing. I think there are different workflow when you work with regular TypeScript code versus script.ts code. I think this is I think this first, I would say, big, maybe it's a surprise if you're just coming from regular TypeScript, JavaScript world. So I'm going to just pause a little bit here to see what you guys think.
Yeah, so as I understand, there's just certain types in the script TypeScript that it doesn't support all of the TypeScript types, basically.
Yes.
That's my understanding.
Yes. So this is one example. As I said, you can think of TypeScript. script.ts is a subset of TypeScript. So in that sense, TypeScript is a superset of script.ts, right? So not all TypeScript code is valid script.ts code. So this is just one example. The types, we do not support this type in property. A lot of reasons. For example, number is fixed length, so it's not arbitrarily big. Versus Bitcoin, right? Bitcoin number is is so-called arbitrary length long. So this is one. But also, let me show you another example. This is one. You can say, hey, I want to put something. For example, I want to put this power operator here. Let's see what happened here. Anybody have a guess? If I compile this, will it go through, or for anybody who is familiar with script should be familiar. But anybody has a guess here? If I try to compile it, what will happen? Will this pass or not?
I would guess
What do you guys
not.
think? Okay, we'll see. All right. Okay, let's run the lottery. Okay, bingo, you got it. So it's not, this operator says it's not legit, basically. Anybody have a guess why? Okay, so for people coming from script or Bitcoin script world, the power operator, basically, that's fundamentally because Bitcoin doesn't have a power operator. That's no op power, because that's just the way how it defines, because mostly because it's op power is not going to be, I would say, you cannot determine how many loops you're going to have in advance. So that's why it's dynamic. So that's why it doesn't come out of the box. There are many ways to simulate it, but by default, just out of the box, there's no such operator. So this operator is very often used in TypeScript, JavaScript, right? But unfortunately, we don't have a native way. But you can simulate it, but we don't support it natively. So that's why also it reports error here. Okay, so this is just another example. many syntax that are not supported. But then the question boils down, right? So how do I know whether something is valid ASCII TypeScript code versus just regular TypeScript code? So anybody who has a guess here? How do you know whether some syntax, before I even run this, how do I even know whether this thing it should pass or not? Compile type check. So okay, so I think this I'm putting a little bit of hard time on you guys, but the answer is follow this guide. So basically here it defines all the valid syntax pretty much. When I say, oh, how to write a contract. So basically everything here, it follows this, it specifies all the valid syntax. So the rule of thumb is if you follow this syntax, you're good. But if you're not, most likely it's not valid. So that means, when you write a contract, strictly follow the rules here. This is a subset of all the valid, TypeScript code. There's also valid, ASCII code. So for example, right, when you declare basic types, you can only have three types. For example, when you write a for statement, right, because we only supported bounded loops, so you must strictly use in this form. Any other form is going to be an error. So this is, you can think of this as the spec, the syntax spec for ASCII-TS. Make sense?
Yep, thank you.
Okay. Yeah, I think so. Here, one thing we are internally working on right now is to see, because here, this is, you can see here, right, when I put it here, the compiler doesn't complain anything, right? No, the ID, because it's valid TypeScript, right? So for example, I give one, give another example. Let's say this. Oh, no, not this. Let's see. I just put some random thing here. Okay, now it's going to say, hey, this is not good to correct because there's no operator looks like this, right? So this is invalid TypeScript code. It's going to, the ID is intelligent enough to just tell me at the spot, right? So I don't have to look at all this kind of a verbal string, error, which is kind of hard to read, right? And hard to pinpoint and give it back to this and associate back to the original source code, right? So that's something we're working on right now. So even though we want to detect not only TypeScript errors, but also we want to detect ASCII-TS code errors, so we can report it back, directly in the ID. That's something we are, trying to work on right now. And I think it's probably feasible, but we have to make it, unless we make it work. So we are not releasing it yet. But I think it's hopeful we can, so later on when you compile, you don't have to run the TypeScript compiler to detect the error. We can just report the error in the ID itself. So that's something we are actively working on. Okay. All right, I think that's all I have to show today. So to give a summary, so when you are debugging, when you have errors in ASCII-TS, you should have two types. One is so-called runtime error. So basically the ASCII code is legit code, but when you run it at runtime, it has some logic errors. So there are generally two ways to debug it. One is to use, console log. And the other thing is just using the TypeScript debugger coming from, out of the box from Visual Studio Code. And we showed two ways to launch it. Either you can launch it from the script, the control file itself, or you can launch it within your test file. So both ways, because it's just TypeScript debugger, so you can do all the normal debugger stuff. You can watch variables, you can set up breakpoints, you can watch, you can step through it, you can step into the function, you can step over it, look at all the variables. And so that's a first type of so-called runtime errors. And the second one you debug is a little bit of a different from normal TypeScript workflow because at the end of the day, not all TypeScript code is valid script.ts code. So we also have so-called, compile time error, which you can only detect when you actually try to compile it. So here, right now, you can only look at the terminal output. We report the error location with the file name and the line, and then some error messages. Hopefully you can correct it, but based on this error messages. I think that's something we are actually improving right now. So if you have any feedback on how to make this even look more intuitive, always let us know. Okay, so I think that's all for me for today. Is just the debugger and how do you fix compile time error. Any final thoughts, comments?
No, I was going to say it seems pretty straightforward. I think just a bit of practice to try all the different methods is key. Yeah, so thank you.
Okay, wonderful. Any other comments, closing remarks? Or we can call it a bank holiday today. Make it short. Okay. All right, and thanks for coming again today. So if you have any, I strongly recommend you, people here or watching later to try this documentation, which also I'm going to, again, always put in the show notes. So walk through these examples, how to debug. You walk through all this code, and all this code is open source. Here, we have an example code, basically shows all the examples that has been, all the script TS code that's been written so far. And we have a lot of examples there. You can try out all of them and let us know. Okay. And the next time I'm going to show you, we have gone through this 3 phases. Next time, I'm going to show you how to actually deploy a contract in the Bitcoin network and also how to interact with the contract. So, okay, I'm going to stop here and hope to see all of you next time. Thank you for coming.
Thanks.
Okay, thank you.
Thank you. Thank you.
Okay, bye-bye. Thank you.